Welcome friends. So in this tutorial I will show you how you can create a universal notebook for your all machine learning task once in your lifetime. You need not to write code again. All you need to write these codes once in your lifetime, and this notebook will become universal for all of your machine learning projects. So make sure that you have to place this notebook within a project folder. So you need to create a project folder like this, and you have to place your data in CSV format in that folder, and you have to make a universal notebook like this. So all you need to write this commands on your notebook and forget, means you need not to write it again. So this becomes your universal notebook. So let us start the process. You need to import 4 libraries from pyMarketLab package. So you need to import this data pre-processing pipeline for data loading and editing. You need to import this EDA for exploratory data analysis. You need to import this feature engineering pipeline for feature engineering and data transformation, as well as feature selection purpose. And you need to import this machine learning pipeline for machine learning purpose. So you need to import these 4 libraries from pyMarketLab. Now in addition to these 4 libraries, you need to import the pandas library also. So let us run this command. You need to give the file name that you want to load. So here the file name is housing file name, so it is there in your project folder. So this file we will load. Now we will load this file. So let us load the data pre-processing panel also. So now it has been loaded. So when you click this load button, your data set will be loaded. So now your data set has been loaded. Now we will check whether is there any date column present or not. If it is present, it will automatically be converted into date time column from string to string, and if there is no date time column, then nothing will happen. So it is saying that there is no date time column to be transformed. So let us move to other process, that is removing the nan value. So when you click on display nan value, it will show the total number of nan value present in each of these column. So you have total bedrooms have total 200 rows which is having the nan value. So we need to handle this nan values with some strategies. So when you click this handle missing value button, you can apply various strategies. So total bedrooms is having 207 nan values, so we will replace it with median value. So when you click handle numerical variables, your nan value has been handled successfully with median. So now your nan value has been replaced with the median value. Another basic editing step we will do, we will remove the outlier. So when you click this handles outlier button, you will be shown a histogram of various columns. So you can adjust the bin size of the histogram by this slider. So let us check the histogram of various columns. So here is the histogram of age, total bedrooms, then median income. So you can set the maximum and minimum range, and you can set the outlier. So based here you can see the quartile ranges are shown. So based on which you can make the decision, like it is showing that the outlier range is 8.01. So you can set the minimum and the maximum value you can set 8.01. so your outlier will be, it will consider rest of the value as outlier. So let us apply this range. So apply this range. Now your data has been updated. So let us check once again the medium income. So now you can see that it has been updated. So in this way you can remove the outlier. Now we will drop the duplicates rows by clicking this button. So when you click this button, your duplicate rows will be dropped. Now you can save this data. So we will save this housing. You can name this data set. So we will say housing edited. Since one file is already present, so I am saying new. So you can give any name and save. Now your process data saved successfully. Now we are ready for exploratory data analysis. So we will run this cell. So you have given the flexibility to load any file. So let us load this file that we have processed recently. So when you load this file, you are ready for exploratory data analysis. So let us create a scatter plot. So you can create a scatter plot simply using this. So a scatter plot has been created. You can also create a geoplot also. So let us create a geoplot. So it takes time to load a map. So let us wait few seconds. So now a geoplot has been created. You can scroll, you can resize the map using your mouse, check for the value. Let us create a unstacked bar chart. So let us create an unstacked bar chart. Let's set a value. So you can create unstacked bar chart like this. Let's create radar chart. So there are many options present in the data set, in the package that you can utilize. So after doing this, we are ready for feature engineering part. So we will name this. We will load this data set, housing edited new data set that we have just done in our previous part. Housing edited new. So let us load this. So once you run this cell, this panel will appear. So load the data set. So you can check the data set. Now we will transform the features. Like we have one category column or string column. So we will encode it, and we need to scale this data set for machine learning purpose. So let us first encode the data set. So we will encode this. So when you click this, your data set will be encoded, as you can see. Save this. Now we will scale this data set. So select the column that you want to scale. Okay, rest is need not to be scaled. Now apply a function for scaling function. Execute. So now you can see that your data has been scaled scaled. So now save this data set. So we will now do feature selection. For first we will calculate the feature score, importance score. So let us select all the relevant column that we want to use and select the target column. Let's select which approach we want to use. Let's say tree based approach, and our algorithm is regression. So let display the feature importance map. So when you click this button, your feature score will be calculated and displayed. So you can see that now your feature score has been displayed. You can see that household has a very less score. Total rooms is also has a very less score. So up to total bedroom we will select, or you can select under threshold also. So we will select medium income, longitude, latitude, housing, median age, population, and total bedroom. So we will go with this. So let us now save this process data. So we will give name housing processed data, scaled data. So let us save this. So our data has been saved successfully. Now run the, we will train a machine learning model, and we will make prediction. So let us load the data set. So we have already saved the scaled data set as we processed earlier. Now we will train a model. So let's select all the values. Let's select the target value and prepare a training data set. So your training data set has been prepared. Now we will split the data set into two parts. So now the data set has been splitted. Now we will build a machine learning model. So let us start with decision tree model. So we are not interested in hyperparameter tuning, so we will do it without hyperparameter tuning, and the model has been trained. As you can see that the R square value for testing data set is 0.57, whereas for training data set R square value is 1. So it is showing that the model has been overfitted to the training data set. So let's try another model. Let's try linear random forest models. So we are not going to again for hyperparameter tuning. So let us run this model. So random forest model is running, and now it has been trained. So you can see that the R square value for training data set is 0.97, whereas the R square value for testing data set is 0.77. So I think it is a well fitted model. Now it's time to make prediction. So suppose we have a new data set. So you need to save this file, new data set that you want to predict. The model will automatically create a data processing pipeline and convert data into into the required form of input. So let's click this button, make prediction. So when you click this button, this widget will appear. So we are interested in regression. Now let's first you need to save the model. So we have saved the model now. So trained model has been saved now in trained random forest model.pkl. So now we will make prediction. So we need to give the name which model we are using to predict, and we also need to give the name of the file that we want to predict. So it is new data.csv. Now let us make the prediction. So now your prediction has been done with the model. Now we will save this prediction. So click the save prediction button and your predictions will be saved in a predicted data.csv. So let us open that file, predicted data.csv, and we will see whether prediction has been done or not. So as you can see that this prediction column has been appeared. So it has predicted. So this is how you can build a machine learning model. And now you can also reuse this Jupyter notebook using this restart and clear output. So all the outputs will be cleared and your notebook will be ready for another machine learning task. So it's a reusable notebook. So all about creating a universal notebook. This notebook you can use with any dataset for machine learning purpose, and you need not to write this code again and again. You just need to copy this notebook in your project folder where your dataset resides, or if you want to place it in another folder you can do also that, but in that case you need to give the full path of your dataset. In case as here we are just giving the name, you can give the full path along with the name of the dataset. So let us end this tutorial here. I think this package will be useful for you because it will save your lot of time. So thank you for joining this session. Have a nice day.